Hello students, today we are solving numerical analysis problems. And this is the second part. We are solving from question this one. They are giving that pi 0 to 1 belongs to R, 3 times continuously differentiable. Suppose that the iterates differ in defined by x n plus 1 equal to phi of n plus 1 converges to xi of phi then the order of the convergence. So for that here we can do that phi of x n equals, so let en equal to xi minus xn. So x of n plus 1 is phi of xi phi dash xi en plus 1 by phi double dash xi en square minus in that way. So the exponent en is the first non-vanishing term. And call the order of convergence. So this is called the order of convergence, so that the order of convergence here 3. So this phi dash xi phi double dash xi, so these two equal to 0. So option number A is correct. Next 10, phi from 0 to 2r is twice continuous differentiable function, and if fx of 0 to 2 is 2 into f of 1, then the error in the approximation we need to find out. So 2 into phi of 1, this is very important over here. So by midpoint rule of numerical integration, okay, so error equal to 1 by 24 phi double dash xi b minus a whole cube. So b equal to 2, a equal to 0, so this is 2 minus 0, so 1 by 24 phi double dash xi of 8, so 1 by 3 phi double dash xi. So C is the answer. The numerical value obtained by applying 2-point trapezoidal rule here. So for the 2-point trapezoidal rule is a to b fx dx. So h by 2 f of a f of b, where h equal to b minus a. So here h equal to 1. So 0 to 1 ln 1 plus x by x dx equal to half of f2 minus f0 plus f1, so half 1 plus log 2. So this is the answer. Last one for this video. L of k of x is this, k equal to this, denotes the Lagrangian fundamental polynomial of degree n and the value of Lk of x. And the Lagrangian value, so this Lk of x will be equal to 1 as Lixj equal to 0 if I not equal to j and equal to 1 if I equal to j. Combining these to get it as 1, so B is this.